Okay, this video is going to finish off our lesson on scatter plots and the whole area about that. So we talked about the line of best fit, and the correlation coefficient is a number that tells us how accurate or how close to all the data the line is. Meaning, if the data is really spread out, it's not going to be as strong. But if that data makes a straight line, it'll be a perfect correlation. So R being greater than 0 suggests a positive or increasing relationship. R being less than 0 suggests a negative or decreasing relationship. The closer the value is to 0, the more scattered the data is, and the closer the value is to 1 or negative 1, the less scattered the data is. So find the correlation coefficient for the cricket chirp data problem. So if we go back to the, I hope I saved that website, there it is. So if we go here, we look down in the bottom, and I can't really draw on this part, but the gives us an R squared number and an R number. The R number is 0.9509. That's a pretty strong correlation. So R equals 0.9509. So it's a strong positive correlation. Okay. Let's go to the last problem. Gasoline consumption in the United States has been steadily increasing. Consumption data from 1994 to 2004 is shown in the table below. Determine whether the trend is linear, and if so, find a model for the data. Use the model to predict consumption in 2008. So we will now go put this in the table. So we're back here in Desmos, and I guess I'm just going to put it in as 94. Take it 94. Oh, that means I got to change my window. Hang on, let me change the window. So we're going from, yeah, I think it's going to mess it all up if I go like 94. Let's do 1994. So I'm going to do re-index this as year 0. And then that corresponds to, oh, I messed that up. That's X1. So year 0 corresponds to, and year 0 is 94. 113. Year 1 corresponds to 116. So let's change these values here on the table. So X will go from 0 to 12. Let's make it -1 to 12. And then the Y will go -1 to, goes up to 136, so we'll say 140. That might be worth a -5. There, we have a little bit of a boundary there. Okay, I think we're starting to see the values come through. Next one, 2 corresponds with 118. 3 corresponds with, let me just do this, 3, 4, 5, 6, 7, 8, 9, 10, and I believe it's 11 of them. Okay, so 118, 119, then we're at 123, then we're at 125, 126, 128, 131, and 136. Okay, there's our nice curve. Not curve, but I mean, you can see a curve in there, but you can see a line coming out of that. So I'd say Y1 is approximately MX1 plus B. And our correlation is 9.898. That's a pretty strong correlation. So it's Y is approximately 2.33333. 2.33333x plus 113. So let's go back here. So Y equals 2.3333x plus 113. So if we look at 2008, How many years later is that? 2008 minus 1994. So that looks like it's going to be 14 years. We look at y equals 2.3333 times 14 plus 113. Let's see what we get here. So scurry about for my calculator. So we have 2.3333 times 14 plus 113. So 145. I should just double check something real quick. 0.67. But hang on. I may need to make this one 15. Did we start that off at year 0? Or yeah, 0 is 94. Okay, so we're doing 14 years after 0. Okay. Well, that works out. So 145.67 would be the number used. Yeah, I'm not sure what. Oh, billions of gallons of gasoline. Okay. That's it for this topic. Good luck. Go forth and do the homework.